In this video, we're going to look at reduction potentials. So this is a continuation of our last video where we looked at batteries. In batteries, you have something being reduced, that is, it's gaining electrons, and something else being oxidized, which is losing electrons. And we say a battery has a certain voltage based on how much one material wants to be oxidized and how another material wants to be reduced. Well, when we actually talk about batteries, we only care about, in general, the reduction potential. But you can't just measure one half cell and get a reduction potential from that. You have to make a battery. And so when we measure reduction potentials, our other half cell is the hydrogen electrode. And so the hydrogen electrode, or standard hydrogen electrode, is going to be our constant when we measure reduction potentials for any material. And we say that the hydrogen electrode has a voltage of 0. And to measure reduction potentials for different objects, we just hook our battery up with our 1/2 cell, in this case zinc, hooked up to our hydrogen, and we measure the electron flows. So here, what's happening is that zinc is actually being oxidized and hydrogen is being reduced. However, since we want to measure reduction potentials, all we have to do is, if we get a number like 0.76, we just reverse the number. So here, zinc has a reduction potential of negative 0.76. And we have a whole table of standard electrode potentials or reduction potentials. So we hook up a bunch of half cells to hydrogen, and we just measure how likely does a substance want to be reduced. So substances that really want to be reduced, like F2 and hydrogen peroxide, they really want to take on electrons, so they have a high reduction potential. Well, elements that don't want to be reduced, that is, they don't want to gain an electron, like our lithium and potassium, they have negative reduction potentials. So things that have high reduction potentials would make great cathodes. That is, they would be great at giving electrons, they would be great at accepting electrons, while elements with negative reduction potentials would be great anodes. They would be good at giving electrons away. And here hydrogen is 0. And so if we hook up a battery, we can measure the battery by E cell equals, we look up the reduction potential for our cathode, that is the thing that is accepting electrons, minus the reduction potential for our anode, the object that is giving electrons. So let's say we're working with a battery of copper and zinc. Well, and we have to ask, which way is this battery going to be spontaneous? Is it going to be spontaneous for copper to accept electrons or for zinc to accept electrons? And so we can do that calculation. So here we have zinc going to zinc plus 2. So that is being oxidized, that is losing electrons, and so that would be our anode, right? So if we look at zinc, it has a reduction potential of negative 0.76. Put that value into our reduction potential for our anode, and we get positive 0.76. Copper here is being reduced. It's going from plus 2 to 0, so it's gaining electrons. So it's our cathode, and so that has a positive reduction potential, so we just put it here for our reduction at our cathode, and we get a positive number of 1.10. If you get a positive voltage, that reaction is spontaneous. If you were to hook up your battery in reverse, that is, your copper is now being oxidized. Well, here, since it's being oxidized, we would put it at the anode and it would be negative 0.34. And our zinc is being now reduced to plus 2 to 0, so it would be negative 0.76. you get a negative 1.1, and this is non-spontaneous. And using this information, we can actually predict if certain metals will dissolve in hydrogens. And what you do is you look at your reduction potential table and you ask yourself, is the metal above hydrogen? If it is, it will not dissolve. If your metal is below hydrogen, it will dissolve. Although, interestingly, most, if not all, metals will dissolve in nitric acid, because that is dependent on nitrogen being reduced rather than the hydrogen. While gold and platinum will dissolve in nitric acid and hydrochloric acid, but not just straight H+. And so here's a reaction of nitric acid, and nitric acid here, that is being reduced to nitrogen gas and water. And that is the reaction that happens when you dissolve metal in an acid. And that's it for this video. I will see you in the next video.